Hi, I'm Angeline Moore. I'm the Troposphere product lead for the Extended Solid Earth Science ESDR System Measures product. And I'm here to give you a brief tour of the Troposphere ESDR or Earth Science data record. Now, when we determine precise positions of the GPS stations, what we're really doing is measuring very accurately the amount of time it takes for signals to travel from the GPS satellites that are orbiting the Earth to the receiving station. But that delay that we measure is a total delay. It's affected by not only the amount of distance between the station and the satellite, but also other factors, including troposphere. So in order to determine the amount of signal delay that is due only to the distance, we necessarily have to figure out how much is due to the troposphere and subtract it out. Now that total troposphere delay can be further broken down into two pieces, one hydrostatic or dry delay, and also a wet delay. The hydrostatic delay is a function of surface pressure, and the wet delay varies according to how much water vapor is in the atmosphere. There are also mapping functions that describe how the signal differs as it is slanted away from vertical. So in the end, what we do is use all the signals that are coming into a station antenna, all the GPS satellites coming through an inverted cone, going down to 7 degrees of elevation. And the fact that the most of the water vapor in the atmosphere is in the lower 2 kilometers implies a cone of diameter 32 kilometers at the top. Further to the delay, if we have simple meteorological instruments on site measuring surface pressure and temperature, we can also convert the wet delay into precipitable water, also known as integrated water vapor. Some stations have these instruments and others don't. There are further details available in our Algorithm Theoretical Basis document, or ATBD, on the website. All the details of the troposphere products, including references. Now, if you're interested in obtaining the troposphere products, from our project website, you can get into the CDDIS, Crustal Dynamics Data Information System. That's our official NASA DAC, or Distributed Active Archive Center. When you go to CDDIS, if you don't have a NASA Earth Data login yet, you can go ahead and register for one here. Once you have that login, then you can come into the archive area, which looks like this, and choose the troposphere products. We're on version 2. Version 1 was from our prior measures project in 2018. And then it's organized by year. Inside of your directory, you'll see one tar file for the entire day, every station. And the products are in this format, Synex Tro version 2. It's a format from the IAG, International Association of Geodesy. And there's a very detailed format document available. Now, if you pull one of those files down and open it up and get one for a particular station like this, this is what the products look like. And again, this format is very, very well described in the specification. You'll get information on the units and other particulars to the analysis in the header. The main observation area is fairly easily read by a human. You can see that there's a station name, P513 here, an epoch, that's year, day, and seconds into the day, a total troposphere delay and its standard deviation, north gradient, its standard deviation, east gradient, its standard deviation, and then integrated water vapor, the measured on-site pressure, and the measured on-site temperature. For stations that don't have on-site meteorological instruments, these last three fields will just have no data. We have a product page on the project website specific to the troposphere product. And you can see the global distribution of stations that we have troposphere products for. This is an example of a very long time series back into 1994, Geoscience Australia's Alice Springs site. You can see that the troposphere delay goes all the way back, but the on-site meteorological instruments weren't installed until the mid-2000s, and so we have a shorter but still multi-decade at this point long integrated water vapor series for this station. We have a couple examples of applications. These include weather applications such as North American monsoon events and atmospheric rivers, and additionally things like correcting interferometric synthetic aperture radar for atmospheric artifacts. This concludes our tour of the troposphere products. If you have any questions or you find these products useful to you, please let us know. Thank you.